Hello again. Once more, welcome back to the cellar. This episode is a follow-on from episode 37, where we looked at how to drive a train badly. Here we're going to look at how to drive the actual layout badly here at Leopard Street. He's going a little bit on why there's the rat's nest of wires, what it's all for, and how it gets used. So, without further ado, let's go and meet Leppy down in the cellar. This is Leopard Street. Right, yes, so part two of the how to drive the train stuff around. So, with the help of my little assistant here, the job of the day is going to be to move the A2 with its nice unpronounceable name. Here we are, Mr. 514, around the loop. Now, as you can see, there's a train in the way, so obviously at the moment we're going to have to wait for that. There's also another train in the way behind, so we're going to have to do something about that. Now, the purpose of this one is how we drive the layout, not how we drive the trains. We saw that last time. So we already know I'm just going to fire up some throttles in JMRI and that's how trains are going to move. But what do we need to do first? Well, let's go and have a look. So here we are back round in the middle, and train wants to go. Can't. Red flag. Not allowed to go. A couple of reasons. Most obvious one being the points aren't set. So, how do we do that? Well, each of these points has got underneath it an SG90 servo, which I don't have one to hand, but never mind. That is controlled from this board here, which is a PCA 9685, which basically tells the servos what to do. That is driven by the ESP32, and there's some little lettering on here which you may or may not be able to make out that says both of these turnouts are one's thrown and one's closed. So the one we want that is thrown, we want that one to be closed. Now, this thing has got some software on it. I'm not going to go geek out into the software in this one. I'm going to do a separate video on that because I'm aware not a lot of people are going to be interested, but it needs doing anyway. What this does, this thing sends the signals over all these wires to the board, tells the servos to move. Fairly straightforward, really. So, why don't we just send the signal to change the points? Well, we could, but at the moment, there's a train in the block. Now, it's stopped for some reason. Moving again. Yeah, man, off you go. Right. Need to clean the track a bit more thoroughly around here. Yes, that'll carry on going up there. Now, Leppy here can see there's no train on that bit of track there. And in fact, electrically, there's a block between there and at the end here, and that has a track circuit attached. So Leppy can not only look and see there's no train there, he's got a little sensor telling him there's no train there. And the sensor, if I remember rightly, right on number 1. So we come down here, and number 1 is down here, and there's no red light on, so that's saying again there's no train here. What it actually means is there's nothing here drawing current. A potential problem, because obviously we could have freight wagons and the freight train has stopped again. So let's just go and have a look. Incidentally, I've been putting some paint on down here on all of this. I had to finish the rest of the modelling compound and put some paint on it. So yes, I suspect the problem here is the track's not very clean and the train is trying to go very, very slowly. Now, when the A2 sets off, the aim is it's going to run round here. Now, this train has just gone past, so I'm going to set that signal to danger. We can't go any further than that. And all we're going to do is go up to that signal. That's the first part. Not going to overly go into how the signalling here works. This is just the way the line is set up. So the first thing we need to do, since we've checked that's there, is we need to know whether we're going to have a train running round. Now at the moment the Q6 is going round, so I'm going to need to stop that, but I need to look at what we can do to allow Leppy to change his red flag for a green flag. So let's go and have a look at the layout board. Now this is JMRI, as the Q6 rumbles slowly behind me. And I control the points by clicking that. Yeah, there's a bit more to it than that. JMRI is only one part of this. This is basically an output. The points at the moment are showing it's thrown, so it's onto the outer loop. As you can see, the red at the bottom is moving. This is as the Q6 moves into its position. I'm just going to accelerate it slightly to here we are rumbling around behind me. What I'm going to do is get it into position, and I'm going to move it until this line here goes red. And what that'll do is tell me that it is just shy of that set of points. So I'm just going to wait for that to rumble round a little bit quicker. See, again, this is the train driving bit on here. As we approach where we're going, you can see more of these little lines changing. Slow down a little bit, and then stop. And there we go. So if I now come over here, we can see U6 is halted. The A2 slightly further back, which is why it's not showing up. So how do we change the points? Well, JMRI currently is showing the point is thrown this way. So how does it know that? Well, back on the little boards, as you can see, I've got other ones over here with the little blue lights flashing. That knows, this is a bit of a cheat. You can set up point servos with switches, and I really don't have one to hand. I thought I had one around somewhere. No, don't. Never mind. Actually, there's two of them tied together. This is what one of the little servos looks like. There's no space for switches on that. I actually created a version of that, which is my little servo mount with some horns sticking out the side so I can stick some switches on it. Thought the original idea was I'm going to put some switches and that's going to tell me where the points are. I thought about it a minute. It isn't. It tells me where the servo's pointing. It tells me nothing really about the point blades. I can imply where they are from where the servo is, but I don't actually know. And I thought, well, if I don't actually know and I'm implying it, and I'm going to have to set up a load of switches, and I'm going to have to calibrate a load of switches, and I'm going to have to maintain a load of switches to make sure they stay in calibration and don't move and sort of get adjusted, why don't I not have the switches? So what I've got is the ESP32, and down here we have the one controlling these points on this board. This is board G, so it controls this one, over here, these, and then the ones in the back eventually. I will set up two imaginary switches, two virtual switches in the software that say where are the point blades. So what I have is, look at this one here, point number 1. There is a virtual switch on this side, which will say this point is in the thrown position. There is a virtual switch on this side, which will say this switch is in the closed position. And when the blades are moving, neither of them will say anything. So, just as a quick one, if I flick this point just manually on here, watch what it does. So there's a brief time where it's not showing anything down at the bottom. And what that is, that's the time where the point blades are moving. And that information comes via these switches. But how does it get here? Well, this is where this antenna comes in handy. See, the connections on Leopard Street are all made over wireless. So this is why I'm using the ESP32 microcontrollers. They have Wi-Fi built in. So that talks to another computer. It doesn't talk to this one, not directly. Upstairs there is a Raspberry Pi sitting on a shelf, and I will insert a little picture of it sitting up there in its innocence, but it's not very impressive. It doesn't do a lot. And that is running MQTT. And that stands for, if I have a little look at the notes I made before we did this, where are we? Good notice. Message queuing telemetry transport. And what that is a little, it's a simple piece of software. It's a broker upstairs, it's a little server. The ESP publishes a message to it, and it has a message for each of the virtual switches. And it says, this is where my switches are. This is what this thing looks like. And it doesn't do a great deal with it after that. But what happens is, JMRI knows about this MQTT broker, and it said to it when it started up, tell me about these switches. I want to know about them. If anything happens to them, let me know. So I'm just waiting for some software to run in the background here as I waffle. And what happens then is it runs, and just show a little bit of software here now. What we have, this is MQTT Explorer, which is talking upstairs. So I go into Track, I go into Sensor, and I come down here and I have DT1 thrown, which is active because the point has been thrown. DT1 closed, which is inactive because it's not inactive over there. Now, if I just move that to the bottom, watch those lines. We've changed the point again. Now, all I'm going to do is click that again. And zoom back, you'll be able to see it. And you'll notice down there, they flickered. And what happens is, first step, the one that's active goes inactive. So they're both showing as inactive. And then the second step is the one that is inactive that it's going to switches to active. And at that point, the system knows. Now, I could have put another little bit of a delay in there. The point blades move slowly. For example, if I want to switch this connection over here briefly, if you watch this, this is how these move. Ready, here we go. Nice and slowly. So, I can use the MQTT system will tell me where the points are, or where the controller thinks the points are. It's an important point to mention. I'm not at any point monitoring which way these points are set. I'm monitoring which way I have told these points to set. It's not quite the same thing, but it's a lot easier to do, and this is a toy train set, so that's the way I've gone with it. And using a similar system, again, if I just show you in here, I can bring up a turnout section. Now over here we have turnout D1, which is saying it's thrown. Well, if I do this, that goes closed. But it flashes a couple of times. Now, these messages here are published by JMRI. And slightly annoyingly, it'll only publish out the closed and the thrown message. Internally, it's got one called inconsistent. So that's what this little feedback line at the bottom is. The ESP32 sets that one. So if I click this, it goes inconsistent, then it goes back. So you can see that it's moving. And this publishes over MQTT, it's just publishing this message, at the ESP32, down here in this case, and over on board D, it's that one over there with a little flashing light on it that you can just about make out. That listens, it sees, this point needs to be thrown. This point isn't thrown, so I will throw it. And it then sends the signals to the servo controller board, which on down here is there. If I zoom out a little bit, is there. Now this one's got a few more connected to it. And that then tells the servo to move. The code uses a timing loop. I could make it change instantly, but instead I've got this little delay in so I can make the thing move slowly. I'll cover how that works when I go through the code. So that's how to change a point. And at the moment, there's no interlocking on this at all. Now, the next signal we're going to drive up to is over here somewhere. So what we need to do is say, well, is there a train in that section? And there isn't, but that's multiple blocks. So that bit there is a block, comes around here is a block, goes over to about there is a block, then to there is a block, and then there's some signals down here. So basically every signal stop point has a short section in front of it that tells the train, if you're in this section, you're now right next to the signal, so do what you need to do. Now we can see now that is clear. So we can get up to this point over here. That'd be good. And we set the signal and it's over there. So what I'm going to do is go and ask Leppy to change his flag, because now we know up to the next signal is clear, but the points aren't. So we will tell the points to change. And note there's points down here that are still set incorrectly. Don't care about that, we'll come back to that in a minute. So let's go change the flag. Right then, Leppy, you've set the points. The route is clear to the next signal. What do we do now? With the red flag, green flag. And that is telling this little loco here, chamois leather, whatever it is, that it can go, but only to the next signal. So let's go and do that. So here we are back at the control station. The throttle is now set for the appropriate locomotive. So if we look over there, I will start her moving. And off she goes. And I'm just going to stop her there, because at this point, Leppy's still showing a green flag. That needs to go back to a red flag. Now I'm going to move that in a minute. But if we look on the board, you can see now this section here is showing active. That is board A. And if you look over there, that is where the locomotive is. It starts just beyond the bridge and it runs up to where the retaining wall ends. That is all one section. So I can move her up a little bit and she'll stay in that little block. I'll get her near the point she's going to stop. So stop there. And the block system's still here. So how does that work? Well, again, I'm going to cheat. Yes, not sure what happened there. Anyway, again, I'm going to cheat and I'm going to show the system over here because I'm stood next to it. Now, these boards, these are the DTC8 boards from Merg. And what we've got is a current transformer, which is what these little black things are. And at the side here are feeds. So one of the DCC feeds, in this case I use the brown wire, comes into one side of this coil, goes round and round, and comes back out again. One end connects to one of these messes up here, which gives it the power feed, and the other connects to the layout. So over there, there's a little board, and you can see there's a red light on. Possibly. Let's just zoom in a little bit. Get this the right way around, which of course I can't. There, I can see a red light. That red light is saying there's something in that block. Oh look, there's a train. That's only picking up the locomotive. The coaches it can't see, so I have to deal with that separately. I've got a solution for that. And what happens then? Back to normal zoom. Come back down here. So this little board says, I've got a train. As you can see, this one here has spotted several trains because there's a few in the yard up here. And it comes out over, in this case, these lovely pink wires. Goes into one of these little boards. So there's two of them here. These are PCF 8575, I think they are. Expansion boards. Now these connect to the same control bus actually that controls the servos. These are providing some inputs and some outputs. I'll come on to what the outputs are shortly when we go around a little bit further. So that goes into there. The ESP32 knows, and what it does is very simply, as we did previously, it pushes these out over the MQTT system. So if I come back over here and bring this up on here, we can have a little look. And in here somewhere there will be a sensor A block 2 active. Yeah, sorry, I'm in the wrong place. A block 2, and A block 2 is that little bit of track there. A block 0 is this bit of track over here, and A block 1 is this little bit here. This is because eventually there's going to be another signal over here. So I need, when the trains are coming in the anti-clockwise direction, I want to be able to stop. This way, they just run out, so I don't need to. And board B, along the retaining wall, is its own section. So again, if I just set the train moving, we look over here, you'll see this whole section here goes red. So we now have a train in there. Now these little merg boards are quite clever. I'm just going to stop again in a moment. Let's get to near the end of this. Now anyone who's run a model train will be aware sometimes they lose contact. Only for a moment, but it'll lose contact. Usually the weight of the train behind it will give it a nudge and it'll start moving again. But here, that can be a little bit of a problem sometimes because this system sees the train and very briefly it doesn't, then it comes back again. And it starts sending messages out backwards and forwards, which is going to cause some confusion. So these merg boards, and this is the reason I love these things, these are very, very clever, have these integrated circuits on there. There's 4 on there. These are timer boards. Now, if you've watched any of Train of Thought's channel, you'll see we've been playing around with the 555 timer, little astable circuit. If you haven't, it's well worth watching, actually. He's done some really good videos on it. Here, these are being used in a slightly different way. These are set up to run for about a second. So you give them a signal, and it puts an output out, and then about a second later it stops. Well, whenever one of these red lights is on, it's being reset constantly. So the output stays on. And then when the train disappears, it takes about a second for it to say, hang on, there's no train here. But what that means is if you lose contact for half a second, 1/10 of a second, whatever, this detector doesn't notice. It just says there was something here about a second ago. Yeah, it's probably still here. We'll wait. And then the train will come back. And that's really useful. It debounces the circuit. It smooths it out. It's a lovely little circuit. It's a really nice idea. So let's continue. And what we're going to do is we're going to move up to here. Now this section here is where the train would normally just run. And we stop briefly. And we can come back here. And see the train is now in this section. We look back over here. That is board C up by the sign. As Leppy's, the stardom's going to his head, let's face it. Now, I'm going to pull up to the signal. Normally we'd be running quite happily along here. We'd get to the point a little bit beyond this. If I come back onto here, you'll see, and what will happen is this bit will change colour. Set it up moving nice and slowly. Wait a second. There we go. Now we hit stop. And as you can see, we're a little bit short of the signal, but this is because we came around at much lower speed than normal. Normally we'd be a bit closer to it than that. But we're going to sit there now, because that signal's at red. And the invisible man who's on duty in that signal box isn't going to change that. Because if we come around here, a couple of things are wrong. This part of the junction, yeah, that's fine. There's no train through the junction. And then we come up to the yard. Now you're thinking, well, it's a 4-coach train. There's bags of space. What's the problem? Part of the rules of the layout, and this is my rule, no train can stop over that junction or that junction. And obviously I'm driving them manually. I can stop them wherever I like. But yeah. This is basically, I don't want trains parked up over the points. So we stop there, practice a little bit closer, and we wait for permission. Now, what this means is no train can stop in this whole section unless its destination is clear. And at the moment, it has two options. It can follow the points as they currently go onto the outer side, onto the storage line, and oh, that's where the Q6 parks. And that is where the Q6 lives. The train may get a little bit longer, another couple of wagons. You can see there's a little bit more space. That is essentially a scenic train. When there's a station up at the high level, the Q6 will not visit. It will just run round on this lower level. But either way, that line's blocked. Oh, so's this one. This one's got my little G5 in it. Now, in theory, the G5 shouldn't be here. These inner lines are designed for trains just to run straight through. They're not really designed for trains to sit in. Obviously, I can store trains, and right now I am doing. The Scotsman's on the line adjacent. So what I've got at the moment is a virtual signal, and I'm going to put that on top of that wagon roof there. That's roughly where the virtual signal is, and that is what the G5 is waiting for. So the next thing we need to do is move the G5. Now he's going to run all the way around there. Oh, Leppy's got a green flag. So before this one can move, that needs changing. So let's go and do that. So here we are again. Leppy's now got his red flag on. I'm not showing this because I've got a duck under the layout, and frankly, it's not very dignified. Obviously, the signalling system here isn't fully completed yet. There will eventually be some signals there. There'll be colour light signals. I've got some of them prototyped around somewhere, but they're not connected yet. And this is purely so I can see what the automation system is doing. Obviously, this is all going to be covered eventually, so you won't be able to see them, but they're going to be there anyway, and I'll know they're there. Now, that flag has to be on red. The points are set. But as we know, before the next signal, there's another train. So the little G5 here can only go as far as that junction. So what I'm going to do now is bring up another throttle. And we are going to move the rather lovely Bachmann G6. What I'm going to do is there, that. Turn the sound on. I love the sound on this thing. I'll just wander over here, you can hear as it just sits there. Hopefully you can hear that. Love the sound of my thing behind the background. So off she goes, and she's going to go round to parallel roughly with the Q6. Now again, while she's moving, if I bring you around here, you'll watch, and this is eventually how this is going to be driven, because you won't be able to see them. So she's chuffing around there on board F. She will hit board D when she goes onto the vertical part of the track. It'll happen shortly. Approaching that junction. There we are, and she's going to go forward a little bit further. Then be told to stop. And if we come over here, there she is, parallel with the Q6. Now note, she's actually in the way because this is where we want to put the A2. But for now, she can run around into this section here and stop somewhere around here, probably. But we're not quite ready yet to throw the points. What we need to do is think about what else we're doing here. Now, on here, this is the point we're going to go over, and it's set correctly. There's a diamond crossing here. And if we go over here, there's another one here. Now, as I said, I've not put any switches on these servos, and these are Electrofrog points and an Electrofrog diamond. How's that controlled? In practice, it's cheating. It's very, very simple. The frogs are controlled by these relays. Boards that have got points have got them. This one's got 8. It's only, I think, going to use 6. Each frog gets its own point. It is connected again to the little PCF 8575, this time using some outputs. So I've got the pink wires are inputs, the brown wires are outputs. When the ESP32 says I'm going to throw the point, it sends the servo instructions to the servo. It also sends an instruction here which changes a relay. And since I need to change these 2 points here, this is as good a time as any to watch. So I'm going to change these. Keep an eye on the little red lights underneath there. There we are. So some went out. If I come back over here, do that again. There we are. See 2 little red lights on. These are wired so that if the power to the relay fails, the frog is set for straight ahead running. And that was done because originally when I set this up, the relays existed, but the control logic didn't. So we got around that. The other thing to note here, this is purely a JMRI thing. These 2 turnouts here are set, so if I change one, it sends out the command to change both. That again is purely JMRI. So that sends out the signal to both turnouts. This picks up both turnouts. They both move. So if we look now, we're set for the dead ahead route on both lines. And because it's a crossover, it never makes sense to set one but not set the other, so they're tied together. They can be moved individually, but I don't need to. So our little friend over there can now be told to move. But before we do that, very, very important, this signals at danger. There we are. We can now go. These are Hornby signals, obviously. They will eventually be probably model signal engineering signals driven by the servo system, which will be run in the same way as everything else is run. So let's bring up our locomotive over here. And she can start to accelerate. And she's now in this block. And again, we come around here, you can see the red line moving around on the layout, just showing the locomotive. This gets interesting, because if I stop her now, according to that, she's on, I mean, this little bit in the corner here is board H. She's apparently on board H. Tail is still over the crossing. So how do we deal with that? Well, at the moment, by looking at it visually. Eventually what's going to happen is this block, or rather this section, which is made up of multiple blocks, there's several on board E, which is that, board H through to board G, that section will say, I'm blocked. And it'll say I'm blocked until the A2 is all the way up here. Because when, say, the A2 gets to about here, it crosses over that board join, the board joins are where the white plastic is, I'll know that it's sitting in this area here, and it's not over there. And what will then happen is, as long as nothing is occupying that block electrically, we'll release it and say another train can come in. The plan is to put brake lights on the ends of all the rear ends, so there's at least something at the back of the train that draws current. So it'll be brake coaches and brake vans. So let's continue. And then what will happen is we'll know the section is physically clear. And because all this is going to be under cover and it's all going to be running automatically, that does actually matter. This is a beautiful little locomotive. Hornby. Well, they're, yes, A2/3. Needs dusting, as does just about everything here. So we shall carry on here, rumbling up slowly, and we've got a train in front, so we need to stop in a minute. I'm not going to stop where the G5 was actually stopped. These two trains are completely different lengths. We're going to go a little bit further forward, and then we're going to stop. Stopping there so that she's clear of this point here. As you can see, the Scotsman and the J52, that's their parking positions. They stop shy of this point by enough they don't foul each other. Yay, sprung buffers. I'm reliably informed by Sam's train that is a quality feature. Personally, I'm not entirely sure how much it's quality and whether it's just a gimmick, but I like it, so I don't care. So in the situation we're in now, it's actually very similar to where we started. What I need to do now, and I'm going to just sort of speed this one up a little bit, is that G5 and this A2 need to swap places. So of course the G5 is going to go round the layout, past Leppy, up the incline, and we'll stop at the signal. And when it's there, the A2 will shuffle round, and there we go. So let's go with this. I'm going to do something terribly naughty now. I'm going to drive a train past a red flag because I don't want to have to duck under here again and crawl over there just to change Leppy's flag. I say he's getting a little bit big for his boots now. And the channel very briefly hit 500 subscribers until somebody came to their senses and thought no. Frankly, I'm amazed. There is going to be a little bit of a catch-up video on what's going on overall, and then we shall talk a little bit more about that. But thank you very much for anyone who does subscribe. I gather it helps with YouTube snowballing things. The more people subscribe, the more things get liked. They show it to other people, so it sort of becomes a thing. And while the idea of this layout becoming a thing and me becoming a thing is quite scary, Leppy quite likes it. He loves the publicity. Now, of course, that signal is still showing clear, but I am actually going to be stopping because the way ahead isn't clear. It's worth noting the actual circuit here has only got, I mean, it's multiple electrical blocks, but it's only actually 3 sections. We've got from ahead of where the Q6 is there, all the way up through the scenic area to that signal. That is 1 section. And a train can stop in that. It's got a signal, so a train can stop. The next section, as I said, is this junction area here. This is, I've referred to as a transitory section. Basically, trains can't stop in it. And that runs to here. And then the other section that trains can stop in is obviously the loops. This means I can run 2 trains at once, but I need to do this little bit of a shuffle. The layout's actually designed to run, as you've seen the automation on the inner loop, of 1 train runs, then the other one runs, then runs again. Right, let's move the... Really useful, the G5 making noise, because I just told that one to move when I didn't want it to. So, let's move the A2 up. So she's going to rumble round. We'll have a look at a little schematic in a minute, which sort of says how all this works. She's going to go around here and very, very, very slightly until she gets into the appropriate position. Nice and slowly. And there, as you can see, both of these 2 tracks over here are now showing as occupied. These are the ones that are, these are basically the stop blocks. Train goes into that block and it's told to stop. So Chamoisière is now done with. So what I'm going to do, incidentally, if anyone got a Linux system and knows how to deal with this minor problem I've got here, comments very welcome. And I managed to move this window so the title bar is up behind the menu. Result, I can't get at it to move it, which is a bit annoying, not too fine a point on it. I can close it though. So, this section is now clear. We can bring the G5 round. So let's do that. And then I shall move over to doing a little bit of a schematic, and I'll explain how all this works in a bit more of a block diagram. I do think 3 coaches is about the right length for that G5. I mean, obviously the real ones pulled more, and I've got more. I just quite like the idea of some trains being a bit shorter than others. At some point I'll get the J72, and that'll probably only have 2 coaches behind it because it's a little bit smaller still. And this, as I've said before, this is another absolutely beautiful little locomotive. This being the Bachmann one that was done in collaboration with the Model Centre and bought sound fitted. So again, she's going to run up here and hit the appropriate stop point. It's possibly a little bit further than that. Because really, I just need to make sure I cleared the points down here. And that'll do. And that's the little run round. So I'm going to set this up for the desk, and then we are going to have a little look at how it all works as a schematic. Yeah, so here we are back at the desk. Let me just adjust a little bit of light over here so that we can see what we're doing. That. Oh, look at that. We've got a bit of light. Now, brown pen, light brown pen. So what we have, in very simple terms here, let's move this around so you can see what I'm doing. We have a set of points. And connected to that, there is a servo, which makes that go. That is connected via some wires to a controller, which is connected again via wires to an ESP32. So ESP32, which is a little microcomputer, PCA, I'm not going to bother writing the number on it. And that physically tells this what to do. And there's power connections. There is also PCF board, which talks to relay, and that talks to the frog polarity. Interesting point to note, there is no physical connection between where the point blades are and the servo and this relay. It's all done electronically. So if any part of that fails, I can get short circuits. This is something I'm aware of, and I made the decision to live with. And then we come over here. Over here, I have a very crude drawing of a PC, which is sat here. It's a Dell Optiplex 790 for anyone who cares. Very old one, done as a bit of a refurb on eBay, but very cheap. And this runs JMRI, and it can run other things. As I said, there's no physical connection between these. My N-Gauge layout, they used Arduinos, not the ESP32, and there was a physical serial lead that went between the two. Here there isn't. What I've got upstairs is a Raspberry Pi 4, and then I have my home wireless, which is just a router that sits in the hallway. And these talk to that, and that talks to that. And on here I have the MQTT software. Now, as we saw in the last one, there is also a connection which also runs off the Wi-Fi, and that goes off to the DCC-EX system, which actually drives the trains. But we covered that in the previous one, so I'm not going to go through that again. But it's all on the Wi-Fi. In fact, I'm that wrong. Yes, Wi-Fi. It's not hardwired. The DCC-EX isn't upstairs. So what happens? This sends sensor data, which goes that way, because this has also got these little current transformer, which actually goes in via that, but I've drawn that in the wrong way. Anyway, that goes up to the track. That's the block occupancy. So we've got sensors for block and sensors for turnout. They go that way. Going this way, we have instructions for the turnouts, which comes back that way. That tells the servos what to do. We also send instructions by exactly the same system for turning lights on and off. So eventually color light signals and stuff will be controlled this way. And that itself is an interesting little point, because JMRI does a lot of what I want it to do, but it's not doing everything. So I'm going to have some other software also running on here, which is going to handle signals. So JMRI, it'll have a switch that says, I want signal D1. I want signal D1 to be at danger. at which point Leppy can put his red flag down and he can come off somewhere else. And then this software will say, I'm going to put out some instructions that say, turn the red light on, turn the green light off, please. But on the other parts of the boards, it'll then send a signal out and say, move the servo, which will move a semaphore signal. But the control system won't care. It will just say, signal, clear, danger. I don't think I'm going to have any distance signals on this layout. I might have. I don't know. I might put one on just for playing around with it. If I do, it'll probably be a fixed distance. So I won't have to move it. So there'll be some logic there. And as I say, this sensors coming back is blocks. So if I just do the quick, and this is a very crude schematic of the layout, as you can tell by the fact I'm drawing it by hand. This comes around here. There is another loop that does that. There is a loop that does that. There's actually a siding that comes back here. This is the DCC programming siding. There is a junction that does that. And then there is a junction that does that and that. This is the rear incline road. Eventually that'll go off up to the station. And what we've got, go to a different pen because I can use different pens. We have section brakes that are basically like that and like that. So all of this red bit is a section and it goes up to a signal. There's another signal there because this bit up here is another section, but that's for the future. It doesn't really work at the moment. It's not really connected. This bit here is a section. And in practice, what will be over here will be two signals, one for each of those roads. It's actually starter signals. But as we said, there's no signals there. I mean, there will be on that side, which lets trains go in, and then over here there'll be a junction signal probably of some sort. So on the outer loop, as we've just seen, we start here. We need to know if that whole section is safe to drive in up to that point. If it is, set the route, clear the signal, go there and stop. But in practice, when we get to about there, that's going to trigger something. And what will happen is the software will look at that and it will at that point say, because this signal will be at caution, of danger, it'll then say, actually, you know what, all this is clear. So I can set the points to be ready. And actually this bit around here is clear now. So I can actually set that to clear before the train gets anywhere near it, and then it won't stop and it'll run all the way back round. And it may stop here. It could just keep going, depending on what I've told it to do. But that, in probably slightly convoluted terms, is how I drive the layout at Leopard Street. Through this system, I can control the turnouts. I can monitor the sensors. I can use that information to make decisions. Just me at the minute, although, as you've seen, I have got some automation running. And what that does is it doesn't look at the layout particularly at all. Starts off here, so the Scotsman's on the inside line. It says go. So she says, right, straight away, set that point, set that point. And we're now clear to run round to here somewhere. And the Scotsman runs out. It's not checking yet whether there's any other trains in the way. So I've got to be a little bit careful with this. And then when it gets to around here, it goes, I'm coming back into the yard. Make sure this point is set for me. And it comes in. And as it comes in, one of these block sensors triggers, the same as a block sensor triggers over here. Train slows down, runs through the yard a little bit, and it gets to here and it goes, well, actually, you know what? I'm doing this twice. Everything's still set. Speeds up again, rumbles round. As it comes back round, it gets to there, and it goes, I'm not going any further this time. So at that point, it tells the train that is here to go. That sets this point, and off it goes. This is a little J52. And then the Scotsman comes round, it hits its stop sensor, and it just stops. So the automation reads the block sensors. At the moment, it just sends an instruction to say to the points, change, go. What it needs to be able to do, which it can't at the moment, is see, there's another train in here. God, I can't draw trains. And because there's a train in this section, you may not go, at which point we're not changing that point because this could have wagons or whatever going on it. All that's for the future. But the infrastructure to do it is here now with the DCC8 block sensors from Merg. And if you're not part of Merg and you're interested in any of this, they are well worth signing up to. It's not particularly expensive per year, and you get access to a huge range of this sort of stuff. So that's the sensors. The servos, there was one around somewhere. Where the other one went. Never mind, I thought I dropped one. Yeah, never mind. It's around somewhere. Yeah, I really don't have the one with the switch ready to hand. That drives. I've got little boards like this, which handle the input-output. And I say I will go through the code at some point. But that's how this works. So, thank you very much for watching. Any questions, more than welcome. Likes, comments, shares, subscriptions, all that YouTube jazz. All helps me keep feeding Leppy and stops him biting me. Don't tell anybody, but he bites me. Anyway, I will catch you all in the next one. Thank you very much and goodbye.